All right. Our final keynote today is someone that I mentioned. I just pick speakers that I really enjoy watching. This speaker I've actually enjoyed listening to so much, I started a business with him a few years ago. So now I have to listen to him every day, So that's how much I like this next speaker. He's really talented. He's given this talk at a number of national and international conferences. So please help me welcome Justin Searls.
Hi, can everyone hear me okay? Seems that way. I hear that the schedule's really thrown off today with the timing and stuff, so hopefully, like, people, if you're coming in, that's totally cool. If you want to leave, that's totally cool. Welcome to my talk. This is a talk that I've given before, so let's open it up in Keynote, just like I did this morning, so we can see this message, which was really scary, but we'll soldier on. I found a backup. The title of this talk is The Social Coding Contract. My name, as Todd just mentioned, is Justin. I'd really love if you're a Twitter person, if you want to find me on Twitter and give me some feedback. My handle is just my last name, or you could email us hello@testdouble.com. So because we are agile in this room, we all understand that open source is good, right? You know, companies are working with other companies, collaborating on tools that, even if they're competitors, they might kind of, serve the greater good and enable new businesses like startups to build brand new products by just building a little bit of custom application layer on top. And like entire new product companies are possible today that weren't before. Similarly, like a single individual working in their basement, writing some code on their computer could really literally change the world and have a really big impact by writing a little library that gets used all over the place by all this different open source. But sometimes, as somebody who spends a lot of time in the open source world, I'm often asking myself, is open source good really? Because companies love consuming a lot of open source, but as soon as you want to share an upstream patch to a library or something, suddenly they're very, very worried about this open source thing and stingy, and they get legal involved, right? Or startups, they love hoovering up all this free stuff, but usually without any understanding of, that they're building these maintainability nightmares simply because they don't understand the stuff that they're standing on top of. So they're like ticking time bombs. And a lot of the maintainers I know are really burnt out because they put their heart and soul into building stuff really for fun a lot of the time. But then businesses and other users come along and they kind of just treat them and expect free, unpaid tech support for life. So that's not fun. So today, my goal is just to put a magnifying glass on a handful of issues facing open source in the hopes that we get in the habit of doing that and being, like Aaron's talk this morning, more self-reflective and thoughtful, thinking for ourselves about open source. And I think that if we did that, we'd start to grow a common set of concerns, and maybe from that we'd generate some ideas, which might lead to creative solutions, and then a little bit of relief, and then we're done, right? That's my path to agility for open source, but this is a really modest talk. We're just going to talk mostly about problems with open source that I've experienced over the years. We're going to talk in 4 different areas. One, we're going to talk about the teetering Jenga tower of dependencies that all of our applications reside on top of. We're going to pull back the curtain a little bit, talk about what it's like to be a maintainer or to run an open source service. Talk about trust in how we market open source and then the security aspects. And then some deep thoughts about how us as open source citizens relate to each other, communicate with each other, and then what I think is going to happen in the future with open source. I like to start talks off with a term definition. So who here knows the term ideology? Like a lot of times we use the term ideology kind of as a shorthand for political affiliation or worldview, but I really like this definition a lot more. They do not know it, but they are doing it. And this definition is sort of like, it suggests that our ideology is the negative space behind our actions. We don't really even actively think that we're doing this because we believe it. It's just what we do. This is actually a quote by a dude named Karl Marx. Open source fans are a bunch of hippies, so I figured that you'd all like if I started with a Marx quote. I actually feel like Marx is appropriate here because that came from Marx's book Capital. And if you think of Capital, it's a book that exists at this intersection of 1, philosophy, and 2, economics. And so does open source, right? People have this philosophy that if we just share code for free, good karma and good things are going to happen. But meanwhile, there's all these companies making boatloads of money off of open source. So let's let's reflect a little bit on economic progress over time and then compare and contrast that with open source progress over time. So economic progress, in the beginning, everything was really pretty rough. We were just all struggling to survive just to get by. And every person was out for themselves. But eventually, humans came along and they formed tribes, and that allowed us to specialize. That means that from one place you might be able to have farmers who you could get your veggies from, a butcher where you could get your meats from. And through the economies of scale, that allowed us to specialize in things that were not necessarily mission critical to survival, right? Like recreation, art, culture started to emerge. As time went on, industrialization emerged as another way that we saved a bunch of time. Now we could go to one store, right? And we could get all of these different commodities, all, one trip to the grocery store per week. And saved a bunch of time, freed up a bunch of time for all sorts of other cool recreations. And the internet has just blown the lid off that, where now from my bed on my iPad, I can order anything I want, and it's at my desk in 2 days, and that's fantastic. But I think that in spite of this progress, we often have to ask ourselves, where does it lead? And it can lead to some discomfortable things. For example, who here heard the rumor a couple years ago that Amazon is actually supposedly using big data to try to predict what you're going to buy and then preemptively shipping it to your local distribution center so that when you click one click, they can do same-day shipping to your house. And that forces a lot of people to ask, man, this is fundamentally changing the game in terms of, what economics has meant as a social system as we kind of hand more and more and more of control to computers in the name of progress. So that's an example of an unintended consequence. Another example of an economic unintended consequence is the industrialization of our food system. And the documentary Food, Inc. was really popular and spawned off a million other Netflix documentaries. And it had this really audacious tagline. It said, "You'll never look at dinner the same way," right? But I feel like it would have been more honest if the tagline said for at least a month. And why was that, right? Why did we all go back to eating beef? Well, the answer is beef's delicious. And also that as we make progress in any axis, awfulness just kind of naturally accretes, even in really big systems. And then what happens is we all have some moment where we freak out collectively and we're like, this is really bad, we should start fixing this. But nothing stops this train right away. Nothing turns on a dime. Instead, the best we can hope to do is identify the problem and then bend the curve. So it only gets a little bit worse before we can start beating down that awfulness. So we're going to talk about dependencies now and the progress of open source dependencies over time, dependency management. When I say dependency, I mean other code that your project uses that you don't write yourself. And in the olden days, we just for example, if we're just having header files and C files, writing a traditional C application, that means that I might write some code, so all of these shapes are the objects in my code base. And I could pull in other code by literally just downloading it, checking it into my source control, depending on it. And from that moment on, it kind of logically lives on as part of my application. It's something I own and I have to carry, which means that it's a hedge against me pulling in too much because it's my responsibility to update it, make sure it's secure, and take care of it from that point on. And that's not very sophisticated. But an innovation was common build systems like make. And what make allowed us to do was we could logically depend on stuff. So we could have dependencies like libxml, for example. And so our app might depend on libxml, but it's in its own directory. We build it, we dynamically link it to our application, and then if we ever need to update it, we can simply curl down a new version and rebuild it again. And we never have to think of it as something that we own, right? It's an external dependency. So we can view our app as just the stuff that we're writing on top. Write once, run everywhere with Java was another big innovation, because now we could write our code on top and then we could find dependencies by just going online and downloading a jar file, and it was super convenient. As long as we took that jar file and we put it on our class path, then we could use that code. And it was just convenient enough that enabled dependencies to get a little bit smaller, right? Because we could just pull in a little thing to do a little tiny job. And it was also convenient enough that they could say, oh, and by the way, to use this jar, we depend on this third jar that you have to pull in. And maybe a couple of our dependencies do that, and we call those transitive dependencies. So a direct dependency is a dependency that your code uses, and a transitive dependency is a dependency that that dependency needs. And this was actually really innovative for social reasons because it allowed alternative language stacks to emerge. So like in Java, you had like traditional Java how Sun wanted you to write it, but you could also have like the Jakarta Commons stack of all the Jakarta and Apache tools that you could pull in. Ruby made this even cooler because tools like RubyGems and Bundler would do a lot of this manual fetching and resolution for you automatically. So you could write like your Ruby code however you like. You could just write in your gem file, I want to depend on these 4 different gems, and then you say bundle install, and it would automatically go find those transitive dependencies and resolve their versions appropriately, and then build trees where even your transitive dependencies have transitive dependencies. Node.js, the recent runtime, is actually taking this further with NPM, Node's package manager. And now I can write a little bit of application code, and I can say, hey, with my package.json, I depend on these 4 things. And what NPM can do, because Node is a little bit different from like a lot of other runtimes, you can actually load the same library multiple times in a single process at multiple version points, which means that NPM, a trivial implementation of it, could suck down all the dependencies, suck down all of the dependencies like a big tree, going deeper and deeper and deeper, which is allowed, like, if you look at Node and NPM, all the modules tend to be very, very, very tiny. And so what you get are very deeply nested trees of dependencies in every given application. In fact, if you're a Windows user, you very often will get issues opened up against projects saying, like, this project literally runs up against the Windows max file path limit of 256 characters. And that's a lot of dependencies. This is like, this is still only a couple of years old. Like, we're finding ourselves really pushing the boundaries of even understanding what we're standing on top of. So all of this, the theme, I feel like, is that we have all this short-term progress available to us for the low, low price of long-term fragility. And Louis C.K., he talked about this in one of his stand-ups, but he just replaced in your mind the word puppy for the word dependency.
It's true, everything that makes you happy is going to end at some point, and nothing good ends well. It's like if you buy a puppy, you're bringing it home to your family saying, hey, look everyone, we're all gonna cry soon. Look at what I brought home. I brought home us crying in a few years. Here we go. Countdown to sorrow with a puppy.
So I write a lot of Ruby code in the Ruby community. Our version of Louis C.K. is a dude named Gary Bernhardt, and he tweeted this a while ago, and I thought it was really clever because it's very true. If you built an application with Ruby on Rails, and it's an empty app usually will have 50 dependencies by default, but any non-trivial app will have 75 to 100. If you simply go away for 6 months and let all those dependencies be updated by their various authors, and then you come back and you try to run update on those dependencies, your app will literally no longer work. And this is pretty much always true, which is shocking, right? But at the same time, nowadays, it's so easy to start a new Jekyll blog, or it's easy to install the Sass gem, or it's easy to generate a Rails app. And the point is, it's always convenient up front and to adopt, but it's never easy in a year. Because it doesn't need to be. All that's important is that you be sucking in new stuff, and that's all it takes to encourage authors to keep pushing out more stuff. So if you look at this big tree of dependencies in a modern application, we tend to talk about our applications on our teams like as what the code that we're writing is. The code that we write, the code that we own, that's what our app is. But obviously, if you think really hard about what your app really is in production, your app really is everything that you ship onto your production servers. And I think that we could benefit from having a mindset shift to be talking about the full blob of complexity instead of just the little tiny candy coding we write on top sometimes. So yes, it's never been easier to write really, really awesome systems that do a million things, but the apps that we're shipping into production on day one have never been, on the whole, more complicated. So I'm guilty of this all the time. Like I said, I do a lot of Ruby, so I write a lot of like Ruby on Rails applications. I might just say casually, oh, it's a Rails app, because that conveys a lot of information all at once. But I never think to say like, oh, and Rails depends on the gem Thor at this very specific version identifying range. I don't even notice that that's true because it's invisible to me. It's hidden to me by my tooling. So the mere fact it depends on that specific version range for that gem means that there are 272 gems in the world that I can't even use on a Rails project because they have version ranges that exclude that range. So it would be really cool if our dependency tools did a little bit more to peel back the invisibility of the dependencies that are not directly dependent on, or transitive dependencies. Like, for example, when I bundle, it would be really cool if our bundle told us not just how many direct dependencies were installed, but how many transitive ones were installed. Or how many gems, based on the versions that we've picked out, how many gems we would not be able to install anymore as a result of all of the versions in our resolution. Or it would be cool if bundle update would tell us, like, hey, if you were to run bundle update right now, we would literally be unable to update 5 gems to the latest version. In fact, since I first gave this talk, I've given this talk like 5 times now, somebody actually committed this one feature to Bundler because of the talk. And so at the rate that I'm going now, because I've got about 20 ideas in this talk, I only have to give this talk, 100 more times. And then everyone will have implemented all the ideas. So if you want to do a pull request on the Bundler project and knock out one of the other 2, that would be fantastic. So if you're a Node.js user, you might look at all that version resolution nonsense and be like, wow, that's really constraining, that's really restrictive. But Node.js, because you can load multiple versions of a library in a single process, that version resolution doesn't affect NPM. So that's awesome, we're better. But you bring all sorts of new problems with the concept, often referred to as multi-loading. So let's say that we have our application on top, and we depend on version C of Orange Triangle. But we have a dependency that depends on version B of Orange Triangle, and maybe it has another dependency that depends on version A of Orange Triangle, all loaded into memory at the same time in our given process. What that means is if I call my version C of Orange Triangle, it might return back like a domain object. And its awareness, it was generated by version C of this thing. Now, it's probably foolish, but I could totally take that object and then pass it into my dependency, who could pass it into version B of Orange Triangle. I read a lot of libraries, but does the library author think about this case that 2 versions of my library are talking to each other indirectly? So is it going to blow up, or is it going to work? The answer is nobody knows. It's effectively like a non-deterministic situation. It's deterministic, but really, really bad, because we're just not sure how it's going to behave. And often, in NPM and in Node projects, you see failures happen in very subtle ways that are hard to debug. Good thing the debuggers are awful in Node. Anyway, let's say that Orange Triangle depends on another dependency called red square. And that author, for whatever reason, decided to give a very loose version specifier for red square. And so in a lot of versioning schemes, if you give it an asterisk, what it means is that at install time, it'll just grab the latest and greatest version of that particular dependency. So if a user installs my library, which is represented by the block on top, whenever they install it, whatever date they install it will determine which version of red square they happen to get. And so one day at TestDouble, we maintain a project called Lineman. It helps you build static assets. It's really fun. But one day, like March 3rd, 2014, every new install failed. And so we got a whole bunch of issues open from March 13th or whatever for 2 weeks of everyone who's trying to install the project, the install would just fail. What we found out was, in this case, the equivalent of red square updated and became incompatible with that version C of Orange Triangle. So now we have a problem, because we contact the author of that dependency to say, hey, control this thing, change the version. He's out to lunch, we can't control him, we can't force him to push up a patch. So then what do we do to fix it? Well, we go and we fork Orange Triangle and push up our own version that we now own up to NPM, up to GitHub. We put out the fire by setting explicitly the version we need for red square. And that effectively solves the problem, but it creates a whole new one. Now we own this dependency that we don't understand or know or need, and if there's ever an important update to it in the future, like a security update, we're not going to get that. And it's a recursive problem. So if that had happened deeper in the dependency stack, it's forks all the way up. We'd have to own everything all the way up, and that's nonsense. So this is what that felt like. It's all my dependencies. So I think that intuitively, of course, the code that you write, you feel like that's the code that you need to do what you're doing in your application. And the code that you depend on is there for convenience. It helps you do your job. And we understand transitive dependencies. I explained them earlier, right? Like, sure, that's a little bit, it confers some complexity, but they need helpers too. But if we go much deeper than that, it starts to feel really risky. And like, how often do we ask about our transitive dependencies? That just feels mysterious to us. And this is why whenever anyone says that they're a full stack developer, they kind of get laughed at sometimes, because like no one understands the full stack of stuff that they're standing on top of in their applications. So yeah, we make fun of make a lot because it's technically inferior to a lot of the tooling that we have today, but it has the benefit of still working. So like if I build an old C project that's 30 years old and I run make, it's probably going to still work. But what are the odds that if I like npm install a node project 30 years from now, it's going to still work? The odds are 0. They're just very close to 0. So that's depressing. So let's change topics. Let's talk about what it's like to be a maintainer and explain how we get into this state so often. So important to note that even though like maintainers might be very visible in the community, they might have a lot of Twitter followers, they might be relatively well known, they are not rock stars, they are just humans. In fact, the way that I look at maintainers, how most people become open source maintainers is they're just like super duper early adopters. How it happens is that a maintainer just goes and Googles for a thing that they want. So maybe it's like, hey, I need SOAP for Ruby. And then they find no results found, so they turn around and they think, well, that can't be that hard. I'll go turn around and build a quick thing for myself and just default to push it up on GitHub, share it with other people. And so a slightly less early adopter, they might go the very next day, Google for the same thing, and see that maintainer's new gem that they just created. So they go and they adopt it and then immediately turn to like Hacker News or Reddit, and they're like, oh, wow, this is really amazing. And the reason that the early adopters share stuff is it's just like if you found some really cool indie rock band that you're really excited about, or some new like microbrew that you think is really, really great. You get excited because you get to be the person to tell other people about it. So they say, wow, this is really neat. And then the maintainer starts to get stars in their eyes, and they find that their ego starts to get kind of wrapped up in the project. And of course, early adopters and people on Hacker News especially are totally jerks. So they'll be like, oh, and it doesn't do this or this or this or this, so it sucks. Now the maintainer's upset again. But because early adopters and extra early adopting maintainers aren't that different of types of people, the early adopters very often will send pull requests or patches to go and fix those things that other people point out as flaws. And now the maintainer's excited again because they're building a little mini community around their project. And so when you think of how a lot of these projects start, you could really sort of express a lot of projects as scratching an itch. So the very first release has got, it might solve a problem, but it probably only solves the specific problem of that maintainer. So from everyone else's perspective, it's kind of lumpy and has some rough edges. And so you think of all of those rough edges as getting smoothed out with pull requests from all of those other early adopters. And after a little while, after some iteration, you ultimately will arrive at something that's a little bit more well-rounded, generally consumable. And that's usually the point that you probably want to say, this dependency is ready for 1.0. It's pretty much ready, it's pretty much stable for an initial major release. But of course, if you're familiar with semantic versioning, I'm really like, I get stressed out about all of the pressure of semantically versioning my apps properly, so I would probably call this like 0.84.0 and just keep on going on minor versions forever, because 1.0 is too scary. But the point is that once you get to that well-rounded phase, actually, you know what? It's never too early for a maintainer to have this conversation with all the people who are offering free patches to their library. They should be saying, like, hey, let's own this together. And I guarantee you, any early adopter is going to be really excited about the opportunity, like, oh, wow, that's awesome, let's do this. I'd even settle for, hey, let's make you a committer, give you access, help you triage issues. Most early adopters at that point in the project's lifespan would be really excited to get that offer. But instead, like, most maintainers just kind of soak up the glory, and they're effectively saying, hey, let's never communicate again. The early adopters are like, all right, bye, and then they're on to the next thing. And so the question in a lot of people's heads is like, why don't maintainers just share control with the people who are submitting to their projects? And I think it's because they misestimate how much happiness their open source projects are going to bring them. Because if you chart happiness over time, initially they got to build a thing that did a job for them, and that's really exciting. Then they received a bunch of accolades from the public about the thing that they built. They're building their personal brand. And then they hit a version 1.0 equivalent candidate, and like things are just going up and up. And their prediction is like they just extrapolate that line. They're like, oh, this is just going to be like onward and upward. I'm going to be the next DHH or Tenderlove, and this is great. As Aaron glares at me. So that's, of course, not reality. And the reason it's not reality is because late adopters are fundamentally different. Late adopters will usually disabuse maintainers of this happiness. From the maintainer's perspective, remember, if you think of them as like an early adopter, this thing that they've published probably already solves their problem, right? It probably solved their problem long before it was even well-rounded. And so it's not uncommon to see them go a week or a month without committing to the project. And in fact, because early adopters tend to get excited about the bleeding edge, a new problem or a new solution might come along that excites them more, distract them, and then they run off to that thing. And a lot of stable projects are just kind of done after a while, or should be. But late adopters might come to that project and see the same situation, but with a very different perspective. They might see it and say, oh, wow, look, no recent commits. That means it's a stable dependency. That's great. 800 stars or forks or 20,000 downloads. That indicates, like, I can trust this thing. And of course, it's open source, so it's free. So that's great. Like, let's pull this in. And I get, like, very often I'll get emails from people. It'd be like, oh, wow, in our company we're going to use your thing, and this is really fantastic. And I forgot that I wrote it, years later even. So if you think of the dependency as like initially serving the maintainer's needs, eventually serving like the maintainer and the early adopter's needs, and you kind of lock it down there as like a concept. Every new user after that has their own needs, right, that are never going to match up perfectly, and so they'll have a lot of overlap, but those areas that the dependency doesn't serve exactly what the user needs out of that library or framework or tool, it becomes a negotiation. And early adopters are usually happy to like just push pull requests or open issues or understand that maybe the library doesn't have to do everything. But late adopters tend to be a little bit more novice or have a little bit more divergent and interesting requirements. And so it's not uncommon at all for late adopters to expect the maintainer to just kind of do it for them. So often just a couple days later, a late adopter might put a stern look on their face and say, whoa, this thing doesn't enterprise my enterprise thing at all. How in the world could it not think about this important use case? And this is where like entitled GitHub issue threads come from. If you've ever seen something like this, the title, missing obvious and important feature, and somebody will rant, like, I thought this was a well-written and good thing, but it doesn't do this silly, nonsensical feature. And I'll reply, and I'll feel bad, genuinely. I'm sorry I didn't know I needed to do that. Could you explain why this is an important feature? And you hope to have intelligent discourse, but then you remember it's the internet. So instead, what you get is all of their coworkers will sign up and create new GitHub accounts just so they can send drive-by +1s. And very often, just pile on and say, this is important. The subtext is the maintainer is bad and he should feel bad. So keeping in mind that because open source is a thing that most of us that submit to it do on like nights and weekends, I'm probably like at the park on a sunny day with my spouse, and now I'm like staring at my phone, stressing out because I just like let down a stranger on the internet. So I say, sorry, Becky, and then I get in the car. I guess I leave her at the park in this example. I get in the car, I run home, and I hack, and I commit some fixes, and I get into the issue. I'm like, look, I just spent all weekend building that thing that you wanted. Can someone please verify it before I close the issue? And then what happens? I never hear from them again. And now I'm really sad, because not only do I have a bunch of shame and guilt and negative emotions about letting down a stranger on the internet, but now I've also done work for free for that stranger and appreciably made this thing that I did as a labor of love, made it worse and made it do a thing that I didn't think it needed to do. And not only that, but now forever I have to kind of dance around that edge case and consider testing that edge case for every new thing that this app or library or tool ever does. And that's really miserable. So you can just, back to the happiness chart, it goes down a lot. And after a certain point, after like 2 or 3 years, ask me about any like 2 or 3-year-old open source repository. In fact, go to my GitHub page if you'd like. It's just github.com/Searls. And I'm having a fire sale today. If you just like pick one and say, I want to own that, I will just give it to you. Today only, just show me your badge and you can have, I don't care. So yeah, late adopters, they tend to expect more niche features than early adopters, tend to be more novice, tend to have more, just sort of feature requests that really only benefit them, because if everyone needed it, it would have come up a lot sooner in the life cycle of that particular open source thing. And so the way that I view that is I feel like late adopters want to be customers more than they want to be users, and it'd be a more effective relationship if they were customers. People try to solve this problem, right, with donate buttons, or sometimes they do dual licensing, like GPL/commercial licensing, or maybe a power pack, like a pro feature gem or library that you can purchase that adds a lot of like enterprise-y business stuff to it, or even paid support or consulting hours. But honestly, I don't think that that really will solve it. I think as long as the motivating factor for open source contributors is like, I'm doing this thing because I love it, having other people do it because their business needs it, throwing money at the problem isn't going to solve the impedance mismatch of why we're motivated to either contribute to this thing or to use this thing. And I feel like we just have to bring out in the open like why this stuff exists. A lot of my open source the last couple of years has been intentionally useless. Like I wrote a programming language called Emo Ruby that is all emoji that transpiles into Ruby, strictly because I knew no business would ever want that. So Isaac is quoting, I think, the show Community here, saying, if you pick a thankless job, you can't be upset when no one thanks you. And that's kind of how it feels. So if you're an open source maintainer, if you're ever interested in becoming one, the important lesson to take is that you should feel free to say no. It takes a little bit of backbone. It's very, very difficult to overcome the shame that you experience by wanting to react to all of the inbound requests that you do something someone else's way. You can always just ask, hey, I'll look at your pull request if you send it. Or maybe, hey, if you fork me, that's cool, and just go work on a fork. Another category of person is somebody who, like a troll, somebody who actively works against you. They're not asking in good faith, they're just trying to get attention, or they're just trying to upset apple carts and watch the world burn. And now remember what I said about maintainers, like they're just humans, they're not rock stars. But we, in this asymmetric internet communication world that we live in, we look at somebody who's got 14,000 Twitter followers, and we think, we've kind of put them on a pedestal, and we kind of think, well, sure, if you have that many followers, there's going to be a couple of trolls in the room that follow that person. But remember, the inverse of asymmetric communication on the web is that if those trolls are 2/3 of that person's mentions, like the communication going to them, they feel the opposite. They feel like overwhelmed with that negative stuff, and not everyone else can see it. So very often maintainers will burn out based on that negative communication. Everyone else in the room is like, whoa, what the hell? Jerry's such a nice guy. We all love him. But his experience is very different. In fact, a lot of times when you see people burn out, that's what they refer to. Seth Vargo, he worked at Chef on the open source project Chef, and he was very active in the Chef community. He's great. He did a lot of really, really great stuff to make Chef what it is today. But he ultimately left the company and left the project because a handful of trolls in the community were making his experience so, so bad. And no one else was around to support him because no one else really saw it, is my understanding. So yeah, trolls, they don't help. And this is usually a point where the maintainer will like cry for help. Hey, I'm burnt out. Can somebody help maintain this? Hello, anybody? But at this point, you're saddled with all these extra features. The buzz around this open source thing is gone. It's way too late to ask for help. Other people are probably not going to come to the rescue and want to maintain this thing that you think is hot garbage. So that's how a lot of open source projects die. So if that's how open source projects die, like what can we do to make them survive? I think that they survive when communities grow alongside them in proportion to their success. If you want to look at a good example, I think the Ember.js community that's grown alongside the Ember.js framework, very large, very vibrant, and has grown almost proportionally to Ember's usage over time. And that's added a certain amount of stability to it where it's a very sustainable build. Relatedly, I think that a lot of companies look at open source as just free stuff and nothing more. It's just like a public good or a public utility that they don't have to pay taxes for or contribute to at all. And so it feels like corporate welfare in a certain sense. And that's certainly not good, and that's not sustainable. In fact, I think that especially big companies, but all companies, should view contributing back to the open source that they depend on as a risk mitigation strategy. Because then if the maintainer does go out to lunch, does disappear, at least they'll have some hands in it to understand it well enough that maybe they can apply security patches or take care of it and run with it if they need to. Also, it's just a fact of life that no maintainer is going to be around forever, regardless of how good of an experience they have. TJ Holloway-Chuck is a person who's published like a bajillion Node modules, and then he just decided one day, I'm out, I'm going to write Go instead of Node, and just kind of had to give out all of his Node modules. But he actually sold a couple of them to like companies without really telling people, and it was really confusing, and we don't have a lot of precedent around this. There's a guy named Why the Lucky Stiff, who was an early contributor to a lot of very important Ruby tools and libraries. And he decided that he was going to leave the internet one day, and he just pulled all of his code down, all of his websites, he stopped resolving. And people had to kind of use their local caches to rebuild it all. And because it was a highly visible person, they were able to do that. But as people do that, it's not always going to be a solution. When I think about this stuff, like that no maintainer is going to last forever, I kind of wish that an application existed that solved this. Like you could imagine an application that you'd go to and it would connect to your GitHub, maybe connect to your RubyGems account, your NPM account, and then we'd use those services to crawl and say, these are the projects that you maintain or that you own, that you contribute to. And just let you opt in, like, do I need help maintaining this thing? Maybe a little like dialog box or like certain types of help that you could basically solicit. And then the inverse is, if you connect these things, it'll show the projects that your projects use. So like as a user, it'll show you like, hey, here's the projects you use and that the maintainer has asked for help on. Contact them inside the app. They want help triaging bugs. Do you want help with that? They want help with security concerns, and you find your specialty and get kind of a matchmaking service for pulling in contributors in a low friction way. There's another aspect that's really sad and difficult, and and part of why I gave this talk was a member in like our Ohio open source community passed away last year. In fact, the last time I really got to hang out with him for any length of time was, oddly enough, at this conference 2 years ago. And he's near and dear to my heart, Jim Weirich. Thankfully, a lot of his tools are still online, still well used. Every OS X system in the world ships with Rake, which he wrote, which he always thought was really cool. He'd go to the Mac store and shell out and see his name on every Mac in the room. He was a really great guy. He's got a bajillion conference talks that are way better than this one on Confreaks if you want to go check it out. But when he passed away, he has a lot of gems, a lot of Ruby gems that I really loved that not a lot of other people used. And so I was tapped on the shoulder and asked to adopt one of them. And what I found was that he didn't execute a will with an attorney that said all of my open source goes to such and such a person. And that became a real sticking point legally for users of it, for GitHub, for Ruby gems. And it took us like 9 months just to get the rights so that we could update it and make it continue to work going forward. So I thought it would be really cool if said application could have a beneficiaries feature. There's a concept in security called a dead man switch from railroads. Like if the conductor dies, they'll fall over and then the switch will get lifted and then the train will slow down and it won't kill everyone. Really? But we could have something similar. Like you could connect to these services, you could indicate like Todd and Brandon are my beneficiaries for all of my apps. And then maybe every 60 days I get an email saying, hey, just verify that you're still able to maintain your open source by clicking this link or replying to this thing. And if I don't, all it would do is add Todd and Brandon as additional owners on my projects, allowing them to continue to push updates and carry the ball forward or delegate to somebody who cares about my stuff. I have a name for this app. It's always important that you name your app before you build it. Just a good agile practice. I like to call this app somebody please make this.io. So you're allowed to change the name, but really somebody please make this, please. Let's talk a little bit about openness and open source and cloud services, because now everything is in the cloud. This slide has got a lot of logos. These are all services that exist for money that are going to shut down someday. And those are for money, right? Like there's businesses behind those collecting money, which is a great incentive to keep your service up and running. But what about all of these centralized services that are there and they're open source? Like RubyGems is an example. It's not a for-profit organization. It's really hard to think of how they'd monetize something like that. And it's a completely centralized system. So what if it just goes away someday? Does that mean we could, like every of the tens of thousands of Ruby on Rails applications on there? Java, same thing with Sonatype and Maven. NuGet and .NET. All of these different repository systems, if they were just to disappear tomorrow, all of the applications, all of those companies benefiting from the corporate welfare of the free stuff would suddenly find like, oh, we can't deploy our apps anymore. That's a problem. And so I ask this because like, since all of our open source infrastructure is centralized, we should be thinking a little bit more about like, how could we make this more sustainable? Either give money or make these foundations more secure, or build decentralized systems. And so if Ruby gems or NPM disappeared, it would obviously be catastrophic. And I think that we could probably we could benefit from asking the question, how would we accomplish the same tooling if we stopped thinking for a minute about how can we make everything more convenient to like, as for the first day of development, how can we suck in as many dependencies as quickly as possible? If we changed our perspective instead to think of like, how could we make this stuff sustainable long term, we'd probably start like answering like, what would the architecture look like of, maybe a blockchain or some kind of like torrent-based system where we could have a decentralized dependency authorization like we have in cryptography. We could probably figure this out, but this is a not sexy problem that not a lot of people will put a lot of time into because you don't technically need it to get up and running on day one. One of my favorite centralized services that I use all the time is GitHub. So if you have two people on a project using GitHub to share their code, every now and then GitHub, especially lately, they get DDoS'd a lot. So sometimes GitHub just goes down. And then the kind of classic joke with Git, if you're familiar with version control systems, is that even when GitHub goes down, you can keep on working. In fact, you can even keep on sharing your code with your colleagues while GitHub's down. But the problem is like, that's not all we use GitHub for anymore. In fact, because the source code of a project is kind of the canonical source of record of like its existence, everything wants to hook up to GitHub. And so all of these integrations exist. Like we pull our dependencies down from GitHub in many cases, or we build our continuous integration off hooks that run on GitHub, or we do our code quality analysis on tools that hook into GitHub, or we literally ship and deploy our code on hooks that run against GitHub. All of our issues in our project management tools are often backed by GitHub data. So when a centralized system like GitHub goes down, we're really kind of, like a lot of our companies are just screwed. So yeah, it's open, but GitHub is still a corporation, and we can only trust it to a certain extent that it's going to keep existing forever. I feel like we should all be a lot more worried about this. But I think that it's, if we were to ask ourselves, like, how would we be able to like allow multiple services to get access to our source code but still avoid that as a single point of failure? It's a totally solvable problem. Distributed version control systems like Git make this really easy to solve, but it's just that no one's paying attention to it. So again, somebody please make this stuff. Please, I don't have the time. I'm already really burnt out. So let's talk a little bit about trust. We're going to talk talking about like open source is all about people sucking stuff in, adopting new libraries. But in order to like get people to adopt your stuff, they have to trust that it's good, trust that it works. And when we talk about like the application architecture of a given app, there's the explicit trust. There's the like I say I want to depend on this thing and this thing and this thing, and that's very explicit. It's clear. Like I know where that comes from. I know its name. I know what it does. But then all of the transitive dependencies, that whole rest of the stack beneath us, is implicit trust. We trust it by happenstance. So like if I depend on one of Dave's tools, I trust that he trusted the right people for the tools underneath him, and it's a kind of a web of trust underneath that. And as our stack gets bigger and bigger and bigger, we do less and less to vet each of those layers of trust in our dependency graph. So, of course, it's worth asking then, how do we get other people to trust us as library authors? And the answer is marketing. And so if you think of open source as something that's actively marketed, even though it's given away as free, you come to some interesting conclusions about our march of progress over time. So if you were to look at like how Linus Torvalds announced Linux in 1991 to the Minix user group, this is the email that announces the existence of the Linux operating system. It's perfectly fine, whatever, but there's no catchy name. He didn't name it in the email. It's bad marketing. He makes a self-deprecating remark right away that it's just a hobby, bad marketing. And he goes off message and says it's only going to work on this really niche hard disk that nobody else owns. Terrible marketing, right? So this is Linux. This is the thing that runs most of the operating systems, like most of the servers on planet Earth. But if it were to release today, it wouldn't even make the front page of Hacker News. It wouldn't even make the front page of Reddit, because our expectations of marketing of open source has gotten so high. If we go fast forward 8 or 9 years to like Java, this is the Apache Ant project. It's a build tool for Java. And you can see, like, look at all the things that they had to do to try to convey "you can trust me" to the audience of that era. For example, they had a logo of a little ant and a triangle. That was pretty cool. Look at all the website stuff. I mean, part of it's just 90s, but they had a mission statement for their project, right? Nobody got time for that today. And they had a foundation affiliation. Being part of the Apache Foundation told consumers, in businesses especially, like, oh, I can trust the Apache Foundation because they have this 800-page book of how they do stuff. But nowadays, we have so many more dependencies than we had then that we don't have time to vet them all and read all of their mission statements. So nowadays, what you typically see is a README file on GitHub that's written in Markdown. So you go to the page on GitHub, you scroll down, it's all formatted in the same font, really easy to read. So what we expect is a quick introduction. And then we expect like a quick and easy installation steps. Here's the method you call, and here's the outcome that you get. Really, really easy. And then lately, especially, you start to see all these mostly green badges up on top. If they're green, then you know you can trust it. If they're red, you don't know if you can trust it. That's how GitHub works. It's not really how GitHub works, don't trust it. So yeah, it feels like it's become an arms race, especially as big companies like Twitter and Facebook start actually like actively sponsoring their open source tools for various reasons that are usually very indirect. This project right here, very well-designed web page. It's a tool called Yeoman. Google is backing it and funding it. And you can see that they have gradients on the page. It's really fancy design. They have an authoritative tagline that says it's really important. They have this one-liner. You run like just one line, and then it walks you through a long tutorial that does everything for you automatically. It's really easy to use. Very good marketing. And it brags about how it can generate 1,000 different things for your project. And in my opinion, it's like a totally bad idea to have 1,000 things that you can generate from this tool, but it's been very successful because it's very, very well marketed. And all of the optimization what you can learn from looking at the marketing is that everything's being optimized for quicker, lower friction adoption of dependencies and almost nothing else, nothing beyond that, nothing about sustainability or building better software, just building it faster. So one of the ways that we do that, I said maintainers aren't rock stars, but we do use the celebrity status to kind of identify. It's like, oh, that's a module from TJ Holloway-Chuck. I can trust that this is probably pretty good because he's very prolific. Or it has a lot of stars on GitHub. That's cool. That means a lot of people use it. Or a lot of forks. Or maybe we can look at how active and how good they are at clearing out issues and stuff from statistics from GitHub. Or one thing a lot of people look at is how many times that dependency has been downloaded, even though that statistic is totally bunk and garbage because it's downloaded by continuous integration servers hundreds of thousands of times. Semantic versioning, I mentioned earlier. If you're not familiar, semantic versioning is a very rigorous way to apply version numbers to software. And somehow we all survived as a species for the last 40 years without having this very rigorous system for versioning software. And yet we feel like we only needed it in the last 3 or 4 years. And the reason is we have so many dependencies now that we only have time to like afford a glance to understand, is this thing safe to use and is this particular upgrade safe? And so now we have this very, fancy versioning scheme that is all about making it easier to adopt software more quickly. And that's all just explicit stuff. No one has time to vet transitive dependencies, even though, granted, the more people you trust, the more people you don't even realize that you're trusting or that you're trusting indirectly. I think it's important to understand open source's marketing so that we can all identify when we're being marketed to. It's not like marketing is not inherently good or bad. I market all the time. Hi, I'm from a company called Test Double. We're a local software agency, and I'd love if you wanted to work with us and do a project. But you know that I'm marketing to you when I say that, and so you filter it appropriately, right? When you don't know that you're being marketed to and you just kind of blindly trust what people are telling you in a context where you're unsure, it's very easy to be led astray. And that's why I think it's important for us to have that awareness. The other half of trust is talk about a little bit about security. I think that it's actually possible, like a lot of times you talk about how security through obscurity is the worst. But I don't think it's actually the worst. I think you can do worse than security through obscurity because While it's very cool that open source code is accessible to everyone, you might be familiar with the old, I think it was a book even, The Cathedral and the Bazaar of, if you have many, many eyes on a particular project, then you'll only have shallow bugs, and people fix stuff really quick, and the security stuff won't be there for very long. It'll be very safe. But that's only technically true that the source code is accessible to everyone because it depends on people actually reading it. So if you ask who actually reads the source code of all of these myriad dependencies, you have a very large group of people who claim to read source code, and then the very small minority of people who actually read source code. You have the people who fork a given project, and the tiny, tiny minority of people who actually do anything with their fork. You have people who have commit rights to a project, and then the one person on the project who does all the work. You have people that send a pull request, but then the very tiny group that are anything more than just drive by once and see you later, pull requests and patches. And then you have the last category of people reading source code, people hunting for exploits in security stuff in software. And that's the only group where 100% of the people are reading the source code. So in absolute terms, even though it looks like everyone reads the source code, it's like a lot of them are bad actors. Bash, which has been around forever and ever almost, is a program that ships on every single Unix machine. And last year, it had a very well-branded security bug called shell shock. And basically, it meant that every single Unix system on Earth that ships with Bash was very trivially easy to exploit until you updated your bash. Very, very scary. And in this world where we pull in so many things, like in the Internet of Things, if you have a smart fridge in your house, it probably shipped with bash because everything runs Linux. And guess what? It probably doesn't have a way to update its own software. So now you're just stuck with a fridge that other people can hack into forever. So as part of this talk, for the research for this talk, I actually went to read the source code for bash. And it was ugly. There were global variables everywhere. There were side effects everywhere. I read a lot of code, and this was hardly readable to me. And I looked at just the one method that was actually the vulnerable method for this particular exploit. Here it is. When I looked at this method, and then I thought about Aaron's talk this morning, I thought, man, if only this code was homeopathic. Because then it would be less code and more white space, and that's easier. If you look at this vulnerable function, the very first interesting command in this is a for loop. And you look at the for loop, and you're just like, man, that is string index equals 0. This is not an usual for loop. The second clause is actually doing an assignment instead of a comparison, and then the third clause does nothing. If I was writing this for loop, I would have written it like this. And the problem with somebody who reads a lot of code and is on a lot of software teams is whenever you see anything weird, you assume that it's meaningful. But of course, in practice, a lot of weird software is meaninglessly, it's accidentally creative. And so it makes it really difficult to read this stuff. And so yeah, theoretically, somebody could have read bash for fun on the weekend and gone through that vulnerable function and found it. But the truth is that very few people do, and very small groups of people tend to hold the keys to the kingdom. And so the Free Software Foundation, which actually, they own bash, they manage bash, they'll tell you the solution is not proprietary software. It's not to suddenly hide the source code so that it's harder for people to exploit it. The solution is instead to put the energy and resources into auditing and improving free programs. And I think it's a valid point. Until you ask, who out there wants to audit the quality of code that literally everybody else depends on? The answer is nobody. Nobody wants that job. That's a totally thankless job. That sounds terrible. And yet we all understand that it's a common good that somebody ought to be doing. There's a paradox at play. Because as a tool becomes more and more popular over time, the importance that we audit it increases. So think of bash on this curve. Bash is one of the most popularly adopted pieces of software on the world, so of course it's very important that it be audited. The problem, though, is that our motivation to audit the thing decreases drastically as the thing becomes more popular. So in the instance of if I were to grab some currency gem for my Ruby project and it only has 10 stars, I'm probably going to read how it does all of its math to make sure that it actually works, because not a lot of people use it and I'm not sure that I can trust it yet. But likewise, if I think well, bash is on 4 million computers, that's not my problem. Surely somebody else is looking at that. I have almost no individual selfish interests that would motivate me to audit bash, because if it turns out that there's an exploit, no one's going to blame me for not looking. So it's an example of, if you're familiar with the phenomenon tragedy of the commons, a shared resource that we can all claim to not be culpable if we all tear it up and use it. So it's not my problem, it's really nobody's problem until it's too late and it becomes everybody's problem. That's no good. And this is a great story to tell your business if they are under the delusion that open source is a free lunch of any sort. It's not that open source is bad, it's just that to be good citizens and to understand what you're actually getting yourself into, every company should realistically, and I was kind of kidding at first when I thought about this, but I talked to some friends who work at big, Silicon Valley companies that have a lot of open source. They literally now are starting to get in the habit of paying people to audit the major pieces and components of open source that they stand on for exactly this reason. And I think it's something that businesses, even smaller ones, probably should be thinking about. The last thing I want to do is just share some thoughts with you that are more general. First of all, this talk has a lot of stick figures in it, if you didn't notice. I drew them all out painstakingly as a clever ruse to lie to you. And the lie is that it confers the idea that open source is this thing that humans do with other humans in a context where it's like people talking to people. But of course, how we actually communicate is email, GitHub issues, and Twitter, and all of that is just asynchronous text. That means that to most people, we're no more than like an avatar and a username, some emoji maybe once in a while, but otherwise text on a screen. That means that when I'm raging at my computer, nobody can hear me scream, right? There's no emotional conveyance in 99.9% of the communication that I have with other people online. Evie had a really, I think, clever and sadly too true of a tweet. It's effed up that a lot of modern discourse seems to be optimized for whoever has the fewest feelings and the most free time. I think there's a really good summary of what open source feels like as a maintainer. So if there's ever uncertainty, or ambiguity, and maybe that leads to disagreement between people in open source, or a simmering disdain, and this is just as true for remote distributed teams as it is for open source, I think it's really important for us to ask, how are we communicating? Because honestly, in those situations, email is probably not the smartest medium to communicate via. Instead, in fact, this is a lesson I learned from Todd several years ago on a difficult project. Whenever you're finding disagreement, try to bump up to a higher fidelity form of communication. So instead of asynchronous text, maybe even synchronous text, like instant messaging would be more effective, because then you could explain your thinking when people react differently. Or if that doesn't work, you could always use an audio call, hear another human's voice, and if their voice is quivering, you can actually see that you're making somebody else cry if you do something like maybe a Google Hangout or a video chat. And then, of course, as a last resort, we have conferences like this one. You could always make the effort to meet up in person. And there's something weird about human biology that when two people who are totally, completely acrimoniously engaged on a particular problem, if you put them in a physical space together and then you lock the door, eventually they make amends. They find some sort of common ground. But I have not found that to be true on Twitter yet. This is also a great strategy against trolls. So if you have anyone who's actually just trying to make a mess of a situation, remember that trolls get their power from two things. One, anonymity, and two, a perceived lack of consequences. And so if you tell them, if somebody seems like they're being a troll, be like, all right, cool, let's have a Google Hangout about that. And suddenly they realize that they would be unmasked and their power goes away and they just disappear. So pro tip about trolls. So instead, it'd be really cool, I think, if GitHub and all of our open source tooling that's so popular thought about this stuff and made it easier for us, lower friction for us to jump the stack higher and have more meaningful conversations with each other. So if this is a GitHub issue comment box, instead of just close issue and comment, it'd be cool to have a button that started a chat with a Gitter as a tool that lets you have chats in your GitHub projects. Or build a live example with something like JSBin right in place as part of the thread that people could see and engage with to actually working software over documentation. It's a cool idea. Or they could schedule or start instantaneously a pairing session, maybe on a Nitrous IO box or with Screen Hero or something, to get people on the same screen to solve the problem in a more human way than just blatting out arguments on issues. So That's a little bit about the social side, but I think that when you think of all of these different trends that I've been speaking about, it's easy to get kind of caught up asking, like, well, where are we headed? Like how do we extrapolate this? So, because in fact, I already tried to. I said, hey, we're here right now, and it's going to get worse, right? So if it gets worse, like, what happens here? Like, what does it look like right before it starts getting better? As I was thinking that, an acquaintance who's a really prolific in Ruby and JavaScript and Rust, named Yehuda Katz, gave a talk at Gogaruko, and he had this quote. He said, Rust is a programming language. Rust enables a whole new generation of high-level programmers to write systems-level code. And so I read that, and I thought, like, wow, that's scary. Like, high-level programming languages where all this mess is happening, systems-level code is like the last bastion of like well-understood software. That's not good, was my reaction. And I kind of tweeted with them about it, and I realized that we were speaking over each other. But then as I spent the weekend chewing on it, I realized, you know what, I'm okay with this. This might be okay. Because when I think about innovation over time, sure, innovation started at systems-level code, like closer to the metal, stuff like physical instruments and embedded software. And then over time, because you need lower-level systems to build higher-level systems like websites on top, over time, the innovation that we saw in open source, the kinds of tools that help drive how we build open source stuff, naturally went up. So the last 15 years, almost everything about our open source culture and the tooling that is married to it is really kind of coupled to web development. But if you look at the very recent trends, the last 2 or 3 years with languages like Go and Rust, a lot of the innovation now is happening back in low-level systems again. It's just a really interesting kind of swing of the pendulum. So the question, though, is that if today's dependency culture is all wrapped up in our concept of web applications where we can kind of run fast and loose, how does this translate if we just port that, cargo cult that over to embedded systems? Now, if you know like some web programmers and you know some systems programmers, you probably have observed that system programmers tend to be more conservative and cautious. And that's, of course, because they are simultaneously isolated from innovation, and they tend to have curmudgeonly dispositions, which is, I guess, a ungracious way to say that they have a certain amount of accidental cautiousness and a certain amount of intentional cautiousness as systems programmers. And part of that cautiousness, both the real and the imagined, is because embedded systems tend to have very grave consequences or potential consequences for failure. So for example, if you were to think of like the worst possible thing that could happen to a website, like with healthcare.gov, right? That was bad. It was like 60 news cycles of America just tearing to shreds how bad this website was. But when you think about it, like, yeah, that was pretty bad because people couldn't sign up for insurance, but really, they couldn't sign up for insurance for a term that was starting in like 5 months. So yeah, that was bad, but it's not like, it was life and death exactly. In fact, if you think of like, what's the worst thing that could possibly happen to an embedded system, with embedded code? Literally, like this is a robot that does surgery. If this has a bug in it because of NPM or Node.js or whatever, like the same kind of concept, people will literally die. So it's much more grave, it's much more important to consider fault tolerance in embedded systems typically than what we're used to in the web. So simply cargo culting it clearly won't work. And so I talked to one of my friends who was an aeronautic engineer when I was working on this talk, and the way that he put it was that he felt like when he adopts a dependency, it's outsourcing their understanding of how to do a part of their job, part of the job of the system that they're building. So you can think of it this way, like if you have a dependency and you have like this application that you're building as a systems engineer or whomever, the overlap of those things is you get some amount of convenience for that, but everything in that shaded area is what I like to call understanding debt. That's something that's like, it's part of your system's job, and it's very convenient, but the problem is you might know what it's doing, but you don't necessarily know how it's doing that job anymore, and that represents a certain amount of risk. Now, in the web, in systems that are easy to iterate upon, you can pay down understanding debt by just simply iterating. You release some code, you observe how it works in the wild, and then you can adjust. But if it's hard to do iterative releases, then you really shouldn't outsource very much understanding, or you're literally putting out and shipping stuff that you don't understand that might break in ways that you can't fix later. So if you compare hosted systems like web systems versus most embedded systems, hosted systems typically run in a centralized way. Embedded systems might be fabricated and shipped. Hosted systems usually have short lifespans. Embedded systems might be rated for a long time. Hosted systems have small teams. Embedded systems might have an RMA process if they have teams at all that are long-lived. What I mean to say is hosted systems have teams that run for the lifespan of the system. They're continually working and maintaining it. Hosted systems usually nowadays have more than enough RAM and CPU to insulate themselves against very inefficient dependencies. It's not a big problem, but embedded systems often have to calculate exactly the resources that they need. Hosted systems are, of course, very connected usually, very easy to patch. So we have continuous delivery even, they might be getting updates constantly. But embedded systems may have very little or no network connectivity. All of that to say, hosted systems, web, where open source tooling kind of grew up and matured, we're in places where it's really easy for us to iterate. That means that there's a lot of room for error. But it's very hard to iterate an embedded system. So if we start to take some of the same tooling, we have to account for that. So that means that systems engineering requires a much deeper upfront understanding of what it is that we're building. So if you try to compare the depth of understanding between something like a web application and something like a landing gear component in an airplane, you might need to know a certain amount of depth on the web app. Before you ship, you might need to know how HTTP works, get request, pull request, the life cycle of a request and a response. But on the plane, you might need to know a lot of things about how planes work and what this landing gear plugs into, and a lot of other variables like air pressure and all this stuff that plugs in order to be safe and sufficiently understanding of what you're shipping. So if we take the traditional web application architecture of we write a little bit of code on top and then we stand on top of a mountain of dependencies on the web and we simply translate that over, what we end up with is this danger zone, right? This is an understanding that we have outsourced to dependencies and we don't know how it works, but we really, really need to understand how that works in order for us to be confident that this system is safe. And so what normally happens in systems engineers is they A, use less dependencies, and B, move a little bit more cautiously. When they do use a dependency, there's a meme of some sort. I think it's called qualified tools. So they will actually go and rigorously prove, sometimes to the point of exercising mathematical proofs, to know that a dependency does what they think it does, which I have never done and don't have time for. Wouldn't want to do. So yeah, most open source tools, they're a product of web development. But if you want to view this positively, even if it kind of is bad at first or hard at first, the way that I look at it is simply today's perspective was very much informed by the web, by the last 15 years of open source tooling. If we start to build a lot of the same tools again with both learning what we learned about the web, but also they're contextual. These tools like Rust has, Yehuda built Cargo for Rust, which is the equivalent of bundler in Ruby. So another dependency management tool. He built that understanding that systems code has different priorities. So my hope is that in the future, what we might actually take back from those systems level tools a little bit of perspective and have a broader perspective in the future so that systems engineers might, reciprocate some of that cautiousness and understanding that's so important at the lower levels that's so clearly lacking, at least in the last 15 years, in high-level systems. It's been a while. We've been talking for a long time. I actually used up all my time somehow. Wow. Covered a lot of ground. As takeaways, I want this to be a positive message. I really feel like open source can be better. Companies really have a responsibility to be hunting for bugs, investing in the stuff that they're building, strengthening stuff with auditing security. Startups, I think, have a responsibility to, as engineers, have a responsibility to startups to tell them, look, either understand the stuff that you're building and move a little bit more slowly, or if you can't afford to move slowly, then be willing to throw away version 1. Of your application, and understand that long term you have to understand what you're shipping in order to build sustainable software that you can continue to change effectively. I like to call that the slow code movement. And then for maintainers, it's really important that maintainers, A, pull in other maintainers early on in the process, and B, that we as a community start to feel find a way to lower the friction and the barriers for us to volunteer and opt in to help other maintainers with their projects, whether it's via a tool or just changing of social norms. So that's all I got. My name again, Justin. I'd love if you tweeted at me. I know it's the end of the day, but if you want to chat, I'll be out front for a while. I'd love to talk to you, especially if your team could use some other engineers from our group. We'd love to work together. If you are looking for a job and you're an engineer and you're looking for a cool opportunity, please chat. We'd love to talk to you. Or if you want to just email join@testdouble.com, we can have that conversation later. And also, I brought some stickers. So if you want a little TD sticker, it's both our company and also it's a very cursive, fancy way to do a table cell in HTML. I'd love to give you one. And yeah, again, just, you know what? Thank you very much for all your time. It was a long time, long day. Really appreciate it. And I hope you guys have a great evening and a good time at the rest of the conference.